Today we talk about Fermat last theorem. Fermat last theorem. Fermat last theorem. Imagine the point. The point, if you imagine the point not in one dimension or two dimension, was only in three dimension. This x-axis, y-axis, z-axis. Even the point in three dimension, not in one or two. If we have a line, the line also in three dimension, not in one dimension or two dimension, only also in three dimension. If we have the squares or rectangle in also in three dimension, not in one dimension or two dimension, only in three dimension. Everything in this world is three dimension. If we have a cube, the cube also in three dimension. If we have a cube like this, we have three dimension. This one dimension, two dimension, third dimension. 1, 2, 3. If we have a triangle, the triangle x, y, z. The triangle perpendicular in this A, B, C. The triangle perpendicular in B. This is the new law. The new law of Pythagoras theorem. This new law. If we have power n or exponent n, x to n plus y to n plus x squares brackets z to n minus 2 x to n minus 2 brackets plus y squares brackets z to n minus 2 minus y to n minus 2 brackets equals z to n. This law is different than Pythagoras theorem. Because why is the difference? Because the Pythagoras theorem only contains in this x to n plus y to n equals z to n. And this addition is not contained in Pythagoras theorem. A. If we use the natural number, if n is bigger than 2, why Pythagoras theorem is not correct? Because the Pythagoras theorem is not complete. Because Pythagoras theorem don't contain this equation. Okay. N equals 3, x equals 4, y equals 3, z equals 5. If we divide this triangle in small pieces, small squares, like this. Okay. After that, if we separate to 4 squares, this 3 times 3 equal 9, 4 times 4 equals 16, 5 times 5 equals 25. If we take like this, if we make like this means that 3 times 3 equals 19, like this. Okay. Also, if we take if if we take 4 times 4 equal 16. This like this. If or 5 times 5 equal 25 like this. Okay. X to n plus y to n plus x squares bracket z to n minus 2 minus x to n minus 2 bracket plus y squares bracket z to n minus 2 minus y to n minus 2 bracket equal z to n. 4 cube means this force. 1, 2, 3, 4. 4 times 4 times force. This 4 times this 4 times this 4 equal 16. And 3 cube. 3 this 3 times this 3 times 3 times 3 equal 26. 4 squares. 4 squares means this 4 times 4 equals 16. 5 to 3 minus 2. 3 minus 2, this means this the same dimension in this cube. In 15, in this 15 times 15, 5 times 5 times 5. 5 times 5 equal 15 times 25 equal 25. 25 times 5 equal 125. 5 means that this 5 is this dimension. It's the same dimension, this dimension. Minus 4. 4. What's the 4? Because this, what's the difference between this 4, this and this? Because they are one row difference. Because of that, we take the difference between 5 and 4. Equal 1. 1 times 16. 1 times 16 equals 16. This 1 times 6. 4 times 4 equals 16. Time 1 this equals 16. Because this become 5. Become in this cube become equals. What's the difference between this and this? Okay. 3 cube means 9. Okay. 3 cubes. 5 to 3 minus 2. 5 to 3 minus 2. 5 3 minus 2 that equal 5. 5 that means this direction. We have this dimension and this dimension and this dimension. In this dimension, there are difference between this cubes and this. Because of that, we take the difference between this cubic and this cubic. The 5 minus 3 means if we take the difference between 3 and 5, we have 2 rows. 2 rows is more than. We need to become this 5 and this 5. What's the difference? We need 9 times 2. 9 times 2. This 9 times 2. This 3 times 3 times 2 equal 18. This 18. If we collect this, we get 91 plus 16 times 1 plus 9 times 2 equal 125. This become 91 plus 32 equal 125. 125 equal 125. If z equal 5, y equal 3, z equal 4, n equal 12. If we apply this equation, this new theorem, and you get, if you apply this and you compute, you take in last this 48 million 228,125 equal 40,828,125. If we take n equal to 0, if we take n equal to 0 and we apply this equation exactly, we take in the last 1 equal 1. Okay. If we have n equal to if we have n equal negative number, n equal -2, z x equal 8, y equal 6, z equal 10. If we compute this, we get 1.01 equal 1.01. If we n equal to fraction number, n equal half, x equal 4, y equal 3, z equal 5, x to n plus y to n plus x to n bracket z to n minus 2 minus x to n minus 2 bracket plus y to n x z to n minus 2 y to n minus 2 equals z to n. This too good. If we take exponent equal half, we get in the last, we get this equation 2.23. If you cannot compute by your hand or your mind, you need computer or you need a calculator to calculate this. If exponent is equal to half, you can get this. The proof of the theorem: x to n, y to n plus x to 2 bracket z to n minus 2 minus x to n minus 2 brackets plus y to n bracket equals z to n minus 2 minus y to n minus 2 bracket equals z to n. If we have n to equal to 2, if we n to equal to 2, x to n, x squares plus y squares plus x squares bracket z to 2 minus 2 minus x to 2 minus 2 bracket x squares bracket z to 2 minus 2 minus y to 2 minus 2 bracket equals z to n. X square plus y square plus x square bracket, this 2 minus 2 equals 0. We get 1. And also y to n 2 minus 2 equals 0. We get 1. 1 minus 1 equals 0. 0 times x squared equals 0. Because this in we get 0 plus x to z the we get y to 2 minus 2 equals 0. Also we get 1. 1 minus 1 we get 0. 0 times y equals 0. Because of that we get x to 2 plus y to 2 equals z to 2. This equation is Fermat Pythagoras theorem. This Pythagoras theorem. This equation is Pythagoras theorem. This equation equals Pythagoras theorem. Because this Pythagoras theorem don't contain this part of equation. This part of it, x to x squared bracket z to n minus 2 minus x to n minus 2 bracket plus y to y squared bracket z to n minus z to n minus 2 minus y to n minus 2 bracket equals z to n. If we get Fermat's theorem, x to n plus z y to n plus z to n minus 2 x to z minus x to n minus 2 x to x squares plus z to n minus 2 y squares minus y to n minus 2 y squares equals z squares. If we consider, if we take x to n plus y to n plus z to n x squares minus x to n plus z to n minus 2 y squares minus y to n. We cancel x to n with x to n and y to n with y to n. The equation becomes z to n minus 2 x squares plus z to n minus 2 y squares equals z to n. If we get x z to n minus 2 out the brackets, inside the brackets x square plus y square equals z square. X square plus y square in this equation equal this equation equal z squares. This quantity equals z square. Z to n minus 2 z squares equals z to n. If we get 2 out from here, we get z to n equals z to n. Why the Pythagoras theorem does not work if n bigger than 2 or 0 or negative number or fraction number or rational number or any number? Because Pythagoras theorem is not complete. Why Pythagoras theorem is not complete? Because the Pythagoras theorem don't contain this quantity, this addition from x to n bracket z to n minus x to n minus 2, and also here x squares z to n minus 2 minus y to n minus 2 bracket equal z. Because the Pythagoras theorem don't contain this part and this part. They absent in Pythagoras theorem, because the Pythagoras theorem not work if n is not equal to 2 or negative number or because Pythagoras theorem is not complete. Why Pythagoras don't work if n is a negative number or any number, because Pythagoras theorem is not complete. They don't have this equation, this part and this part column. They absent. That is thank you for watching.
اطلع